Welcome back, everyone. We're going to be talking today about adding and subtracting polynomials, um, which involves a lot of the same methods that we've been using thus far. They're just building on each other, and we're using them all together now. You're going to see, multiplying binomials, squaring binomials, multiplying monomials with binomials. It's a lot of the same stuff you've seen before, just kind of all put together now. And order of operations definitely matters, as it did before, but now we're just doing it with more advanced expressions. So without any further ado, let's get started on going through this. Okay, so in question 1, it asks if 2 times the quantity pq minus 1 squared minus the quantity pq plus 2 squared is equal to p squared q squared minus apq minus 2. We have to find if it's true or false. So we're going to multiply the left side out and see if it looks like the right side. So what we need to start with here is evaluating this binomial, or this expression, and this expression, the squaring of two binomials. So let's first jump over and let's evaluate pq minus 1 squared. And the reason we have to evaluate those first is because we have to evaluate in order of parentheses and exponents. Well, the expressions in parentheses can't really be combined anymore because they involve variables with numbers, so you can't simplify that anymore. So we just have to provide that multiplication out. So for the first one, pq minus 1 squared, as we discussed in the last video, this would be evaluating pq minus 1 times pq minus 1, because it's the expression squared. We're multiplying it by itself. So we're going to use the FOIL method, first, outer, inner, last. First is pq times pq. When we multiply pq times pq, the p's can combine together. If you're multiplying them, become p squared. The q's can also be combined together, become q squared, because you're multiplying them. Or if you want to think of it like a monomial squared, can be the same as pq squared. Since these two variables are being combined by multiplication, you can just distribute this exponent inside. That's a different way to think about it, if that makes it easier to think about for you. I'm going to rewrite this squared because my 2 kind of fell off a little bit. Okay, so we have p squared, q squared. Okay, so that was the first one. The outer is pq times a negative 1. Make sure you account for that negative. So you either have plus negative pq or just minus pq. And then the inner is negative 1 times pq again, so we have minus pq again. And then negative 1, or the last, is negative 1 times negative 1, which is positive 1. So that's that expression evaluated. Moving over, we have pq plus 2 quantity squared. I'm just going to do this over here so we have more room. Very similar process. We have pq plus 2 squared. Notice, too, that I didn't bring this negative over, because just like the first, or just like pq minus 1 squared is being multiplied by 2, pq plus 2 squared is being multiplied by negative 1. That's what that minus sign is doing. But we have to multiply that after. We can't distribute that in until we evaluate the expression. Okay, so we have pq plus 2 quantity squared. Okay, so now we have pq plus 2 times pq plus 2. So the first, we have pq times pq. Same logic as last time. It's going to result in p squared q squared. And then outer is going to be pq times positive 2, so plus 2 pq. Oh, hold on, I'm sorry. Just want to check something. Oh, and I'm sorry. slight segue because I missed a step. Very last thing we have to do is combine like terms. So we're going to end up with p squared q squared minus 2pq plus 1. My apologies for that. That was a slight oversight in my on my end. Okay, back to the problem at hand. We did first and first outer. Now the inner is, again, 2 times pq, so we're going to have another plus 2pq. That kind of rhymed. And then last is 2 times 2, which is just plus 4. So this one is going to be p squared q squared plus, combining like terms, again, we're going to have 4 pq plus 4. Okay. Now if we go back here, I'm going to change colors for this just to keep things separate. So now we have 2 times p squared q times the whole quantity p squared q squared minus 2pq plus 1. And the reason we have to include this whole expression is because this 2 is being multiplied to pq minus 1 squared, the whole quantity. So we have to distribute this 2 back to the whole quantity we found over here. And then, so I'm going to separate this just for the sake of, or on 2 different lines just for the sake of room. So like I said, we are multiplying this next one times -1. So we have, I'm going to represent that as plus. We have -1 times p squared q squared plus 4pq plus 4. Okay, so now we have to distribute this 2 to everything in here. And then we have to distribute this -1 to everything in here. So what we're going to end up with is, from the first line is 2p squared q squared. 2 times -2 would be minus 4pq. I'm sorry, plus 2. And then from the second line, we're going to have minus p squared q squared. Erase just so we have a room really quickly, because we already we evaluated that one already, so we can get it out of the way. Okay, so we have minus, then minus -1, or I'm sorry, we have plus -1 times p squared q squared, so it's minus p squared q squared. -1 times 4pq would be -4pq, so that'd be minus 4pq. And then -1 times +4 is also a minus 4. And now all that we have left to do is combine like terms. The like terms being the p squared q squareds, the pq's, and then the numbers. So we have 2p squared q squared minus p squared q squared. So that gives us a grand total of just 1p squared q squared. In terms of pq's, we have -4 and -4, so that'd be minus 8pq. And then we have a +2 and a -4, which would result in a -2. Which, if we compare that to the right-hand side of that true or false statement, we see that this is actually true. Okay, so the next one is a little bit different, but it's the same idea. We're gonna, we have to evaluate parentheses, exponents, multiplication, division, addition, subtraction, follow order of operations. If you notice here, we have an overarching set of parentheses. So we have to evaluate that expression or simplify it as much as possible, that expression inside those outer parentheses, before we can do anything else. I mean, you could multiply this x squared in separately, but to avoid confusion, it's easier just to save it for the end, follow order of operations. Okay, so what we're going to have, we have x squared minus x times x plus 2. Well, what we can do here is, since we have x times x plus the quantity x plus 2, we can distribute this negative x inside. So what we're going to be left with is x squared on the outside. Inside the big parentheses, we still have x squared. But negative x times x is a negative x squared, and then negative x times positive 2 is minus 2x. Okay, so now we have x squared minus x squared. Those terms go away. So all we have now left is x squared times negative 2x. And then, x squared times x is x cubed, and the negative 2 is still the coefficient. So we have negative 2x cubed as the answer. Alternatively, I'll show you what I was talking about before. Alternatively, you can, if you wanted to, we have x squared times x squared minus x plus 2. What you could do, since technically this is a monomial times a binomial because it's two terms separated by subtraction, even though this has multiplication in it, what you could do is you could distribute this x squared to the x squared and to the x right here. So you'd be left with x to the 4th minus x cubed, and then you still have to keep what this is multiplied by, which is x plus 2. So what you have now is you have to distribute this x cubed inside these parentheses. So you have x to the 4th. Negative x cubed times x would be negative x to the 4th, and then negative x cubed times positive 2 is minus 2x cubed. Both of these cancel, and you're left with the same answer. I just personally think that to avoid confusion, it's a little bit easier to evaluate what's in the parentheses first and then distribute that variable or that monomial term in. But do whatever works better for you or makes more sense to you. Whenever I do videos, I try to think of, different possible ways to do things because, there's not a one size fits all thing for math. There's different methods, and whatever makes sense to you, you should do. The method on the left just makes more sense to me personally. But like I said, do whatever suits you the best, because both of the ways work. You can see they both give you the same answer. Okay, now we have longer ones. We have we don't really have any foiling or anything to do. We kind of just have to see what all of our like terms give us. Now, normally you'd start with parentheses, evaluating what's in parentheses, although they're all polynomial expressions. You can't really simplify them down anymore. You can't combine any of the terms like with each other in here and here or in here. So what we have to do now is see what other kind of multiplication can be done. We have it with here, we have a positive 1 multiplied by all those, so we can drop the parentheses. We also have a positive 1 times y squared plus 2y plus 5, that whole quantity, so you can drop the parentheses there too, because it's not going to change. We're not multiplying anything different to it. It's not going to change at all. So we have now y squared plus 2y plus 5, and then we can say plus a negative 3y is just going to be minus, or plus a negative 3y squared is just going to be minus 3y squared. And then we have plus y, oh my goodness, plus 1. Sorry, I don't know what happened there. Sometimes my stylus just likes to stop working for a minute. Okay, plus y, I think it might just be this part of the screen. I don't know, plus y plus 1. And then here is here is the only place where we're going to have a change. because we have a -1 times everything, so we have to distribute that -1 inside these parentheses. -1 times -5y squared is going to be positive 5y squared. -1 times positive 4y is going to be -4y. Then -1 times -3, or I'm sorry, -1 times +3 is -3. And so now we're going to group all of the like terms together and then simplify. So in terms of the y squareds, we have y squared, we have -3y squared, and then we have +5y squared. And then in terms of the y's, we have +2y, +y, and then -4y. And then in terms of the constants, we have +5, +1, -3. Okay, so 1 minus 3 plus 5, that would give us a +3. So we have +3 y squared, because we're evaluating, or we're, when we're combining like terms, we're just adding all the coefficients together. This was the y squared, so now we're going to focus on the y's. We have 2 plus 1, which is 3, minus 4 is -1, so we have -1y. And then we're focusing on the constants. We have 5 plus 1 minus 3, which is a +3. So we have 3y squared minus y plus 3 when we simplify that down, and that is our final answer. Okay, that's the end for this video. Thanks for watching, and I will talk to you next time.